Welcome back. Mr. Eicher here to teach you lesson 10.8 or 108. Special segments in a circle. This is page 21 in your class notes. If you go over and look in your definitions, we have 3 theorems left. The first one says if 2 chords intersect in a circle, chord AD, chord BE, then the products of the measures of the segments of the chords are equal. So the important word here are the products. The measures of the segments are equal. So notice we have AD times ED equals CE times EB. So this segment AE, the length, times the length of this segment DE, that equals CE times EB. So those products are the same. Now what I have right here is a geometry sketch pad just to show you this is true, theorem. It's inductive reasoning here. So I measured the segments right there. Here's this segment, GD is right there, circle A. Chords don't have to go through the center of the circle. And then CE is right there. So I can move these around, and all these different lengths are changing because each section, each segment is changing. Now, if I calculate GE times FG, okay, so that's 18.04. And then if I calculated this one, GD times CG, okay, notice they're the same. So no matter where I move the lengths of these segments, these 2 products will be the same. So if we move over to the class notes, we can multiply some of these. We have x, a 20, a 5, and a 10. So we would do 20 times x equals 5 times 10. And we simplify that, we get x equals, this is a 50, we divide both sides by 20. So x is 5/2. Pause this video and see if you could do the next problem. So on the next one, looks like you should get 11 1/4. So when you multiply, the setup would be 8 times x equals 5 times 18. So you have, that's an 8. 8x equals 90. So x is 90 over 8. And that sounds like it's 11 1/4 is x. So that's one theorem. It's pretty simple. Just multiply the lengths of the 2 segments. The next theorem that we have deals with when 2 secant segments. Secant, way back here in the definitions, secant line. Secant is any line that intersects a circle in exactly 2 points. So if here's a circle, that line is a secant line. It intersects the circle at 2 places. Do you remember what it's called when you intersect a circle in exactly 1 point? Does anyone remember what it's called? Anybody? Is anybody here? That's called tangent. So you have a tangent line, and then you have a secant line. So we're talking about secant lines here on this theorem. And it's pretty lengthy. It says if 2 secant segments are drawn to a circle from an exterior point, so the exterior point's A, these are both secant, crossing the circle twice, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measure of the other secant segment and its external secant segment. So what's all this with external secant segment? What's all that about? Well, if you notice what we have AC, this external part of the segment, this part, times the whole segment. So it's a little different than the last one. So you have a part times the whole. So you have the outside part times the whole length equals the same thing. So on the next one we have AD, the external or the outside part, times the the whole length AE. So we have the outside part equals the whole length. The whole length. So let's check out some examples. For instance, this third one that we have. These are a little tricky. Students sometimes mix these up. Sometimes I mix them up. So be really careful. You have the outside part is 8 times the sum, the whole length. So you have to take this whole length. This is the confusing part, the part that students often forget, the whole length. So the whole length is 8 plus x. 8 plus x equals, the outside part is 10, times the whole length, 10 plus 24. Not 10 times 24, 10 plus 24 is 34. So distributing, we'd have 64 plus 8x equals 340. We get 8x equals, subtract 64, what's that, 24, 276. And then we have 276 divided by, what was it, 8. 34.5. X equals 34.5. You're asking for x. On the next one, I wanted you to pause this video and see if you can label the circle correctly, label all the segments correctly, and then use that theorem I just showed you to solve for RS, find RS. So pause this video. So we have find RS. So RS, I'm going to assign a variable, let's say x. And PQ is length of 12. QR, the length of 2. And TS is the length of 3. Not drawn to scale, obviously. So our setup would be the external part, the outside part is 2, times the length of the whole segment, which is 14. I don't know, that's a 1. 14. Equals the outside part, x, times the length of the whole thing, tr. So this is 3 plus x, or x plus 3. You could write it either way. So you have 28 here equals 3x plus. Now what is x times x? It's not 2x, it's x squared. So we haven't done many of these, but in Algebra 1 you've seen problems like this. Anytime you have a squared term, x squared, and a linear term, x to the first, you want to set the equation equal to 0 and then factor. So you would have 0, you subtract 28 from both sides. So 3x plus x squared minus 28. But now we would like to rearrange this. So we have 0 equals x squared plus 3x minus 28. And now this is in standard form. The highest exponent goes first, so x squared is first, then the x, then no x's with the 28. And then we factor it. So we need factors of negative 28. X squared plus 3x minus 28. Factors of 28 that add up to 3. So you're thinking of factors of 28. So you're thinking 2 and 14, or you're thinking of 3 and 8. Whoops. Never mind. 4 and 7. Or you're thinking of factors 1 and 28. So you're trying to think of something that when you add them, you'll get positive 3. Notice these 28s are all negative. So one of the two of these factors will be negative. So if you actually use this one, so when you factor, you would have an x and an x. If you use 4 and 7, one of them has to be negative to multiply to negative 28. So the 4 is going to be negative, the 7 is going to be positive. So that's how we factor. You'll see factoring a lot in future math classes, more than geometry. But on this one, you would have 0 equals x plus 7 times x plus 4. When you set both of these equal to 0, x plus 7 equals 0, so x is negative 7. This is the 0 product property. x plus 4 equals 0, so x equals negative 4. Sorry. Messed it up. The 4 was negative, wasn't it? There we go. So the 4 is negative, you have x minus 4 equals 0, so x is positive 4. I knew I did something wrong because x can't be negative, right? If you have a length of a line right here, you can't have a negative amount for the length rs. So you throw out this one, it's not negative 7, the answer must be x equals 4. Okay, to try the next two, this is our last theorem. It's kind of related, actually, to the one we just did. It's a special case. It says this, number 16, if a tangent segment and a secant segment are drawn to a circle from an exterior point, so here's your exterior point, this is your secant segment, passing through twice, this is your tangent segment, touching the circle at exactly one point, then the square of the measure of the tangent segment, so the square measure of the tangent segment, is equal to the product of the measures of the secant segment and its external secant segment. So it's kind of like this theorem, but instead of doing it external times the whole thing, you just do this twice. So you're going to AE, segment AE, you're going to do that times itself, which is the same as AE squared, equals the external part AC times the whole length, AB. So let's see what that looks like on these examples. I'm going to erase this a little bit. Guess I need more space up there. So we have, first we'll do the tangent. We're going to take this length squared, x plus 4 squared, equals. We're going to take the outer one, x, times the sum. So what is x plus x plus 2? X plus x plus 2, the whole length. That would be 2x plus 2. And now, especially if you're Paulina, you really like algebra, and you're going to get to solve this. You've seen these in Algebra 1. If you've had Algebra 2, you've seen these as well. So when you have x plus 4 squared, be careful not to mess this up. X plus 4 squared. X plus 4 squared. It's probably the best to think of it as, maybe to rewrite it as, x plus 4 times x plus 4. You have two factors of x plus 4. That's what the exponent means. So when you distribute, you have x squared plus 8x plus 16. That's using FOIL. If you've heard that phrase before, you multiply the first two, the outer is the O, the inner two, and then the last. Basically, it's a way of organizing your work with the distributive property, is what FOIL stands for. But that's what you get when you multiply those. So, get rid of that. So on this one, we would have x squared plus 8x plus 16 equals x times 2x is 2x squared plus 2x. Now it's a process of simplifying. So how about pause this video and see if you could simplify this. Remember, if you're left with x squared and an x term, you're going to have to set the equation equal to 0. So see if you could do that and pause this video. Okay, so if we subtract x squared from both sides, we'll do that. We'll subtract 8x from both sides, and do that. And subtract 16 from both sides. That would be, basically we subtracted everything from this side. We have 0 on the left. And we have x squared minus 6x minus 16. If you ended with a negative x squared term, then take everything to the other side, and that'll make it a lot easier for you. So we have to factor this. You need factors of negative 16 that will add to give you negative 6. So 8 and 2 will get you to 6, depending which one's negative. You want it to be negative 6, so you're going to have a negative 8 and a 2. So you have x minus 8, x plus 2. And solving that, set both equal to 0. You get x is 8 and x is negative 2. Looking back up here, negative 2 cannot be an answer. Length cannot be negative. So your answer is 8. So that would make this one 12, this one 8, and this one 10. And that is definitely not drawn to scale since, yeah, well, you know how it is. Okay, on the next one, we do the same thing. We take the 3 squared, the tangent 1 squared, equals x times the length x plus 8. And simplifying this, we get 9 equals x squared plus 8x. Set it equal to 0 so you can factor. 0 equals x squared plus 8x minus 9. So you have 0 equals x plus 9, x minus 1. Those are factors of negative 9 that add to 8. So you get x equals negative 9, x equals positive 1. So it looks like the answer is 1 since x can't be negative. Okay, on the opposite side of this page, our last page for chapter 10 notes, we have find the requested variable. These are really similar to the 6 that I just showed you. So I'd like you to see if you could answer these 6 questions. You can pause this video. I'll show you the answers to the first 2 when you resume the video. So make sure you do the first 2, and then you can pause the video again and I'll show you the answers to the next 2. But you should take a few minutes and see if you could answer these questions. Here are the first 2 answers, x equals 3, x equals 7.746. Don't leave it as the square root of 60. Either use your calculator and get the approximate decimal, or simplify it to be 2 root 15. The 2 comes from 60 is 4 times 15. The square root of 4 is 2. So it would be 2 root 15. Now there's no reason why you should have missed this one, because I happen to forget to change the numbers from the one that's directly above it right here. So you should have gotten that one right. At least look in your notes to see how to figure out a problem. Now the next one, you have you should have this work, and you set it equal to 0, and then there's a problem. Finding factors of negative 324 that add to 11 is very complicated. So this is a case where I didn't pick very good numbers to give you a whole number answer. But basically you'd have to use the quadratic formula to solve. I won't ask you one like that on the quiz or on the test, since we haven't reviewed the quadratic formula. But the answer would be this, using the quadratic formula. But again, I won't actually ask you one where you have to use the quadratic formula. They'll be factorable. And the last 2, if you haven't had opportunity for this, you should pause this video and try the last 2. So again, the part that I would guess that you might have missed on this next one is this part right here. This part right here is the complicated part that students often miss. So you have to do the part on the outside, which is 8, times the sum of 8 plus x plus 4, which I have written right here, 8 plus x plus 4, which is x plus 12. And distributing, you get the answer of a half for x. On this next one, again, you do 3 squared, and then this part I would guess you may have missed. If you missed anything about it, it would be x times x plus 6. And distributing, setting equal to 0, and these are the same, so you really only have to do one. This is called a double root, getting the same answer on a quadratic equation. So you would have x equals 3 for this answer. So thus concludes chapter 10. You should know all these definitions. These are the formulas we did today in this lesson, but you have quite a few. Notice all of these. You have inscribed angle theorem, kind of related to this theorem, inscribed polygons theorem that we did previously, and then in these video lessons we've done this theorem and all these theorems today. So make sure that you can keep track of all the different theorems, and I will see you soon. Enjoy the rest of the day.